Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 177. Please turn to page number 177. Today is our lesson number 207, and problem number 181 is what we're going to do, the very last problem on page 177. Here's the problem. It says x is m% of y. X is m% of y, and the question that they're asking is y is what percent of x. Now listen, there are two ways we can go about solving this problem. One is what I call the traditional way, the orthodox way, the classical way, the geeky way, the nerdy way, the academic way, the proper way, the algebraic way. And the other one is what I call the quick and dirty way. Like in the quick and dirty way, we do not do the algebra. What we do is we employ a technique called plugging in. We plug in values for the variables. We make up numbers for the variable, and thereby we convert a fairly complicated algebraic problem into a very simple arithmetic problem. We're going to do it both ways. Let's do the classical way first, so that once we have done the classical way, then you can appreciate how much simpler the plugging in method is. Let's do the classical way first. The classical method that we're about to do right now, that we are embarking on, is not something that I would recommend that you do in a real exam. It is very time consuming, and there are too many pitfalls, there are too many possibilities of making errors. Here's how it goes. We are told x is m% of y. X is means equal, m% means over 100, of means times y. Let's solve this thing for y. So y equals 100x over m. This is your y. This is your y. And then the question is, y is what percent of x? Same exact situation. Y is what percent of x? Y is means equal. What is your unknown? Typically we write, the convention is that we employ x to represent the unknown. Obviously we can't use x here because x here has a special meaning. So I'm going to use, let's make up a new number here. Let's put letter p for the percentage. P% p over 100 of means times x. And we know what y equals to. Y equals to this quantity, so we're going to put it here. Y equals 100x over m equals x times p over 100. Let's see what the question is actually asking. In terms of m, y is what percentage of x? Alright, very good. So you see, x appears here and x appears here. Since it appears on both sides, if you were to divide both sides of the equation, by x, the x will drop out, and m, if you were to manipulate it, m would equal to, I'm not going to do every step here, because as I said, this is only for people who are very good at algebra, who can handle it. And if you're one of those people, then of course you don't need me to show you this baby steps. But if you manipulate it, you will find that m equals 100 times 100 over p, which is same as 10,000 over p. And that's your final answer. And that's answer choice. Oh, plastic. We are solving for p, the unknown. We are not solving for m. We are solving for p. So p equals 10,000 over m. That's it. That's your answer. That's answer choice E. See, that was our unknown. The p was our unknown. This what part is being replaced by p for percentage. So we solve for that unknown in terms of m. In terms of m means in the final answer we can have no other variable except m. We cannot have x in there, we cannot have y in there, and there is no x or y. It's just 10,000 over m, and that's the answer. Now let's do the same problem without the algebra, shall we? Without the algebra, we use plugging in technique, we make up numbers. The thing with the plugging in technique is that when you're plugging in numbers, you have to be smart about it. Plug in numbers that are easy to deal with. Now, since we're dealing with percentages, I like to plug in numbers that are multiple of 100. So let's say here, x is, let's ask ourselves, x is 25% of, let's say 200. Now why did I put in 200 here? Why did I put in 200 here? Because 25% of 100 would be 25. 25% of 25% of 100 would be 25. That would be x, and then x will end up being 25, and m will end up 25, because it will read 25 is 25% of 100, which is fine. There's nothing wrong with it, except when you're plugging in, you mustn't have the same value for two different variables. Each variable must be designated by a unique numerical value. That's how you distinguish one from the other. That's why I did not put in 100 here. So now the question is, 25% of 200 is what? 25% of anything is 1/4 of the thing. 1/4 of 200 is 50. So now this thing reads 50 is 25% of 200, which of course is true. And the question is why? This is the question. The question is why is what percent of x? So we substitute our number. Our y is 200. So 200 is what percentage of 50? Can you tell me 200 is what percentage of 50? 200 is 4 times 50, obviously. If it's 4 times 50, that implies that it is 400%. That's our answer. That's our punchline. The answer is 400%. All we have to do is go through all the answer choices. Wherever we see x, we're going to replace it with m. Wherever we see x in all the answer choices, we're going to replace it with 50. Wherever we see m, we're going to replace it with 25. Wherever we see y, we need to replace it with 200, until we get hit upon an answer choice that gives us 400. Let's do it, shall we? Let's do it on the top. A says 100 times m. 100 times m. It doesn't really matter what it is. M is what? What was m? You got to keep track of your work here. M is 25. 100 times 25 does not equal 400. A is not the answer. Let's look at B. B says 1 over 100 times m. That's definitely not it. We're looking for 400. Let's look at C. Answer choice C says 1 over m. That's definitely out. 1 over m would simply be 1 over 25. M is 25. That's not it. D says 10 over m. That's not going to help. 10 over 25. That's not it. We're looking for 400. That's not it. Let's look at E. Answer choice E says 10,000 over 25. Now, we're not going to be silly enough. We're not going to sit there. I was going to use another adjective, but I stopped myself. We're going to break it up. Don't try to divide 10,000 by 25. Learn how to save your time a few seconds here and there by taking the exam in a smart way. Just because it says 10,000 over 25 doesn't actually mean that you have to divide 10,000 into 25. Divide and conquer. Let's write 10,000. Let's write 10,000 as 100 times 100. 100 times 100 is 10,000, because 100 times 10 is 1,000. The 10 times would be 10,000. Divided by 25. Now I could not tell you off the bat how many 25s are in 10,000. That would require a couple of seconds for me to figure it out. But I could tell you how many 25s are in 100. 100 has 4 25s. 4 times 100 is exactly what we're looking for. 4 times 100 gives us the 400 that we're looking for. The answer is E. So that was one way of doing it, by plugging in numbers. And this is another way of doing it via by means of algebra. It is your call as to what you want to do. I prefer to just plug in numbers in the exam, keep it simple. Do you understand? Algebra is nasty sometimes. I'll see you tomorrow, okay? Bye now.